we present Beyond True or False, Retrieval-Augmented Hierarchical Analysis of Nuanced Claims. Scientific and political topics are increasingly being consumed in the form of concise, attention-grabbing claims that lack the nuance needed to represent complex realities. Such claims are frequently oversimplified or confidently stated, despite being only valid under specific conditions or when evaluated from certain perspectives. For instance, a claim like vaccine A is better than vaccine B may appear straightforward, but becomes inherently nuanced when certain aspects, such as efficacy, safety, and distribution logistics are considered. Moreover, stance detection categorizes opinions as supportive, neutral, or opposing relative to a target. However, documents, especially those in a scientific domain, often present a range of stances across various aspects of a claim. This demonstrates how stance detection at the document level is ineffective for nuanced, multifaceted claims. Furthermore, existing fact-checking frameworks overlook evolving scenarios where fine-grained scientific claims may be unsubstantiated due to a lack of research or a lack of scientific consensus, rather than being outright false. We address these challenges using ClaimSpect, a framework which systematically deconstructs and analyzes claims by leveraging large language models. ClaimSpect hierarchically partitions a claim into a tree of aspects and subaspects, enabling structured validation and the discovery of perspectives. We assume as input, the user provides a claim and a corpus, where each document in the corpus does not need to necessarily be relevant to the claim. We first utilize an LLM to generate an initial set of reliable, coarse-grained aspects to guide the retrieval-augmented hierarchy construction. Then, in order to construct a rich, coarse-defined aspect hierarchy that's aligned with our corpus, we must gather rich document segments from our corpus that are likely to discuss these aspects. We define a high-quality, discriminative segment as one which discusses the aspect in depth and does not discuss the aspect sibling in breadth or depth. In order to determine whether a segment discusses an aspect in depth, we must first enrich our understanding of the aspect. From our corpus, we initially retrieve segments relative to the aspect and prompt an LLM to determine the aspect's relevant keywords. We then rank a segment based on its discriminativeness. The discriminativeness score is comprised of both the target and distractor scores. We compute the target score based on the average semantic similarity between a segment and the target aspect's keywords. We compute the distractor score based on both the mean similarity between the segment and all of the distractor aspect keywords, and the max similarity with a single distractor and its keywords. We utilize the target and distractor scores to then compute our overall discriminativeness score, which weighs the proximity between a segment and its target aspect relative to its overall and individual proximity to the distractor sibling aspects. We then utilize these top discriminative segments as in-context knowledge for prompting the model to determine a set of sub-aspects which would typically be considered when evaluating its parent aspect. Ultimately, we continue constructing our aspect hierarchy in a top-down fashion until we reach the maximum depth threshold. We use this final aspect hierarchy as the basis to determine the different perspectives within the corpus towards the aspects and their respective consensus, or lack thereof. With the aspect hierarchy constructed, we must identify the complete set of corpus segments that 1. Pertain to the root claim, and 2. Align with an aspect node in the hierarchy. Pinpointing papers that discuss an aspect node allows us to infer their perspective towards it and assess the present and extent of consensus surrounding that aspect. We first filter out claim irrelevant segments using a binary search-based algorithm. Then, we apply taxonomy-guided hierarchical classification to map segments to each node. Given a set of aspect-relevant segments, we prompt a model to determine their perspective towards the aspect. Finally, given all aspect segments and their perspectives, we have the model summarize the corpus's overall perspective towards the aspect. In order to evaluate ClaimSpect's abilities to deconstruct nuanced claims into a hierarchy of aspects, we construct 2 novel large-scale datasets specific to our task. We also devise both node-level and taxonomy-level automatic metrics. First, is the aspect node relevant to the root claim? In the path to a node, is each child more specific than the parent? Are all siblings at the same level of specificity relative to their parent aspect? Is the aspect node unique within the hierarchy? And finally, how many segments are relevant to the claim and an aspect node? Through our evaluation, we find that ClaimSpect excels in granular aspect discovery, outperforming baselines by on average 68% in path granularity and 36% in sibling granularity. This demonstrates the method's ability to retrieve and organize aspects at targeted levels of granularity, thus deconstructing a claim into a well-structured hierarchy of aspects. Second, ClaimSpect constructs a rich aspect hierarchy while still preserving relevance. We observe that ClaimSpect's constructed hierarchy features nodes that are on average 13% more unique than the top baseline. This indicates that ClaimSpect's hierarchies are richer in aspect quality, experiencing less overlap with aspects across the tree and supported by an increase in segment quality. We also note that ClaimSpect is overwhelmingly preferred over baselines, specifically exhibiting a clear advantage where it's preferred 92.95% of the time. We additionally conducted a qualitative analysis of a nuanced claims aspect hierarchy. In this case study, we can see that each coarse grain aspect well represents the various angles of the root claim that would traditionally be considered when validating it. We additionally observe that the path-specific dependencies are reflected within the descriptions of each aspect. Finally, we note that the perspectives mapped to the root node are informative, providing justification behind each stance. Given that ClaimSpect maps segments to each perspective, we can easily identify the original paper sources and ultimately provide a corpus-specific estimate of the consensus behind a claim. In order to assess the validity of the perspectives discovered by ClaimSpect, human evaluators evaluate whether these perspectives are effectively grounded within the corpus. We find that the vast majority of perspectives are supported by at least one specific segment within the corpus. This shows that the perspectives identified by ClaimSpect are largely supported by the corpus. Overall, ClaimSpect allows us to explore the different aspects and perspectives surrounding a nuanced claim in a more structured manner. It allows both us and models to gain a more holistic view of a problem, deepening our understanding of the topic and alternate perspectives. Please check out our paper and code if you're interested, and reach out if you have any questions or are interested in collaborating. Thank you.